And hopefully everything will work tonight. Thank you so much. I need you to keep me on my toes. Okay, um, let me give you a couple of more minutes to work on these two examples. Because if you can do these two examples, you're really up to par in terms of factoring. Okay, I think we should get started on these now. Let's look at that first problem. 3x squared minus 30x minus 72. Both of these happen to be trinomials, three terms. And the question is to factor completely. Now, when I noticed somebody, I think it was Devana who actually did this, she did it totally correctly in terms of the first thing you look for before you start any other work is there possibly a common factor? Is there a number or a letter that goes into every single term? Well, if I look at the coefficients, the numbers in front, there's a 3 here, a 30, and a 72. All of those are divisible by 3. But there's even though there's next term here, the last term doesn't have any x. So the only common factor happens to be the 3. So the first thing I do, and this is any time I do any factoring, I factor out the common factor. 3 into 3x squared gives me x squared. 3 into negative 30 gives me negative 10, so that's negative 10x. And 3 into negative 72 gives me negative 24. You, of course, could use your calculator if it's this is a little bit more difficult. 72 divided by 3 on your calculator will give you 24. Once you've done that, then the next thing you want to do is look what's left inside your parentheses to see if you can factor further. Factoring completely means to go as far as you possibly can. And in order to do that, since it's a trinomial, we're going to use our AC method. That's the only thing, Erica, that I was doing with A and C. The A in this case, the number in front of the x squared, forget about this 3 now. This 3 is just, we'll put it aside. We're only looking at what's inside. The A is 1, the C is negative 2, 24. So the AC in this case is negative 24. The fact that it's negative means that when we split this up, we're going to have one number being positive and one number being negative. Because remember, when we multiply and get a negative answer, one has to be positive and one has to be negative. Not only that, we're looking for two numbers that when we multiply them will give me the 24, but since this is a minus, when we subtract them, it will give me 10. And
6 and 4.
And what numbers multiply to, so the answer is 24, but when you subtract them, you get 10. Not when we add them, but when we're subtracting them. Jonathan, I think I heard you. Right, 12 and 2. It's not 6 and 4, even though 6 times 4 gives you 24. When you add 6 and 4, you get 10, and we don't want to add them, since this is a negative, since that last term is negative, we've got to be able to subtract them. So we're going to have to get a 12 and a 2. Now, of the larger number in that case, I'm just seeing who's I don't know what happened to my people that were wanted. Oh, here. I'm gonna admit them. I'm still admitting people, so that's why I'm stopping. Since the middle term is negative, it means the larger of the numbers, which in this case is the 12, will have to be the negative, and the smaller number, the 2, will have to be the positive. Now we put an x next to each of these and just bring down the x squared and the minus 24. And then I can do my grouping method. Between x squared and 2x, we have a common factor of x. So that becomes, and I'm just going to move this one down. What was it? 4x squared minus 16x minus 9. Was that what that was, right? Okay. So here, between the x squared and the 2x, my common factor is x. And in the parentheses, I get x plus 2. In my second group, the negative 12x minus 24, 12 goes into them. But since it starts with a negative, I have to include the negative. So it becomes negative 12. Negative 12 into negative 12x is x. Negative 12 into negative 24, negative into negative is positive. And I see that my common binomial factor is x plus 2. So I put that in front. I put the x minus 12, the numbers that are outside, in my second parentheses. And then I go back and put that 3 in the front because that was, I don't get rid of it. It's one of the factors. It's the first factor I took care of. Any questions about this? Okay. So this happened to be, notice both of the examples I gave you didn't start out with a regular just plain x squared. They both had what we called leading coefficients. They both started with a number in front of the x squared. But in this first case, that leading coefficient actually turned out to be a common factor of the whole expression. So we got as our final answer 3 times x plus 2 times x minus 12. I saw somebody on the chat, I think it was Devana on the chat, who actually, that's exactly what she got. That was perfect. Okay, so now let's look at that second example. The 4x squared minus 16x minus 9. Now, again, we have a leading coefficient, but that 4, even though it goes into the 16, it doesn't go into the 9. There's no common factor between it. So we just go to the regular trinomial factoring. Again, we figure out what the AC is. Let's put the AC over here. I'm gonna put a line here. So the AC is 4 times negative 9, which is negative 36. So what does that mean? It means I'm looking for two numbers that are going to multiply to negative 36. Now, again, since it's negative, and I'm going to write it right here, one of them is going to be positive and one of them is going to be negative. And it doesn't matter if you put the positive one first or the negative one first, it doesn't matter. But we're looking for two numbers that multiply to 36. And since this is a minus, they have to subtract to 16. Can you think of two numbers that when you multiply them will give you 36, but when you subtract them, you get 16? Anybody? Does anybody have any clue?
Professor,
Right, 2 and 18. 2 and 18, because 2 times 18 is 36. And when you do 18 minus 2, you get 16. And again, since the middle term is negative, the larger number is going to go with the negative. So the 18 is going to go with a negative. And the smaller number, the 2, is going to go with a positive. And now we put X next to each of these, or whatever in this case, because whatever the letter is, and bring down the 4x squared and the negative 9. And in our first group of 4x squared and 2x, we have a common factor of 2x. 2x into 4x squared gives me 2x. And 2x into 2x, everything cancels out. Remember, when everything cancels out, it
You
becomes
put 1.
1. Don't just drop it. It's a 1. Then I go to the negative 18x minus 9. Well, obviously 9 goes into both of them. And since it starts with a negative, it's going to be a negative 9. Negative 9 into negative 18 is positive 2x. Negative 9 divided into negative 9 is plus 1. So that your final answer is going to be, I'm going to put it over here because I don't want to go too low here. The common binomial factor is 2x plus 1. And the other factor is the 2x minus the 9. And it doesn't matter which order you put this in. What would be wrong is if there would be a minus 1 and a plus 9. But it doesn't matter if you put the 2x plus 1 first or the 2x plus 1 second. It's the right answer. Any question about either of these? Both of these are
Professor,
yes.
why there's a 3 next to the x2, x minus 12? Right there in the bottom.
Over
No,
here.
in the bottom, right there.
There's no.
No, you pointed at it. 3x plus right there. Why there's a 3?
Okay. If you notice in the first, when we started this thing out, the whole example had a common factor of 3. And I factored out that 3. And then I just worked at the x squared minus 10x minus 24. When I did that, when I factored the x squared minus 10x minus 24, I got the x plus 2 and the x minus 12. But I had this 3 from before. I have to bring it down because that's part of the answer. I can't just throw it away. Does that answer your question? Bashira?
Yeah.
Did that answer you?
Yes.
Okay. All right. So obviously more practice on this, and I did give you some on Delta Math. You'll see if you go to your Delta Math and the new assignment, there are examples like this. And factoring is extremely important. And I want to talk to you just part of today. It's now 10:20. Here's what I want to do. I want to teach until about 5 to 11. And the last 45 minutes, I'd like to just go through some different examples from previous chapters, from chapters 1, 2, and 3, just as a review, because again, you have this test on Blackboard that you have to do. As of now, you have time to complete it, but we've had 2 quizzes on Delta Math, and now there's a test on Blackboard. It should be available if you want to do it already. Just again, like the Delta Math tests. This is a time test, which means once you start it, you've got to complete it in an hour. And if you start it and then click it off, it's not going to restart for you. If you run into problem like your internet goes down, and we know that happens all the time, just email me. I'm not saying I'm going to see it instantly, but when I see it, I'll reset it for you. Don't worry about it.
Professor,
Even if that happens during a midterm or a final, I'll do that. Yes. Who's asking?
I don't see the assignment on Delta Math.
No, the assignment's on Blackboard.
Oh, no,
The
not the
test-
test. I'm
There
talking
should
about
be-
the examples that you said that you put on Delta Math for us to do with factoring.
No, that's probably not, it'll probably, I don't think it's available yet.
Okay.
Sorry. It'll be available a little bit later. Okay? Now, let me see. Does the test on the Blackboard have a due date? Yes, the test on Blackboard. Oh, I can't remember what I put as a due date. It's one day, I think it's Tuesday. I think it's Tuesday. What's Tuesday's date? Today is the 12th. Tuesday is like the 16th. I think I gave you the 16th as the due date. Again, once you start it, you must complete it in one sitting, but you have until, now, if it says it's due, I'm just giving you an example. Let's say it says it's due at 10 o'clock at night. Don't start sitting at it at 10 o'clock at night or at 9:30, because at 10 o'clock, it's going to just cut out. Okay, Melissa just joined us. I'm so glad you're here, Melissa.
I know, you know how it is. It takes me a while. Sorry.
Okay, I hear it in your voice. Are you ready to, okay, and here's Cheryl. Cheryl, I'm glad you got in.
Ashley's asking that on the test, there is no due date on the test on Blackboard.
There is no due date. I probably, so that, you know what, I'll make the due date a week from today in any case, if I put on a due date. So don't worry about it. The only thing you have to worry about is you have to get it done. You want to get it done before the midterm, because that's what it's all about. It's preparation for the midterm. I will always give you an extension if you need it. I am perfectly happy with giving you extensions. The only thing I don't have control of are the midterm and final. That's departmental. Also, if anybody is entitled to double time, please email me so I can set their test up with double time. There are maybe people who are from the DA that are able to do that. Now I'm going to.
I'm sorry, did you send everyone their grades? Like, did you email everyone their grades?
I did, I sent you out something, every single person in the class, I sent out what I think, and it might not have been an actual grade, it might have been, are you missing material? Are you in danger of failing? I didn't necessarily say, oh, you're getting an A now, but I did send everybody an individual email, and it's on the email from Blackboard. Now, I know some people are not so careful, they have, make sure that the email on Blackboard is the one that you check.
Okay.
Okay?
Thank you. I appreciate it.
I definitely remember seeing, I remember what I sent out to you, Jonathan. Are you, Rachel?
Professor, your internet.
Can you, are you able to check that email? Does it, those emails?
Professor?
Okay, I'm sorry, I got thrown off. I don't know why this is happening to, okay, Rachel, the email that you have listed for Blackboard, that's where the emails are coming to, because when I send out emails through Blackboard. So if you can't change it to one that you use, I don't know why not. I know that you can change it. But if you can, at least make sure you're checking that email address, okay? Okay. So you just have to know that you have to check it on a regular basis, because I do send out emails. Certainly, I send out a notice about the class every morning of class. So you really should be checking those. Just like I have to check my MEC email, you have to check your emails also. Is there any other questions on what we were doing? Okay, so then if they're not, anybody have any questions as to where we're holding, what you should be doing? There should be some examples on, I did put out, I might not have, it might be coming up. Sometimes I predate the assignments on Delta Math so that they're available right after the class where the stuff is being taught. So that's why you might not have seen anything. Okay, what's so important about factoring? Why do we spend quite a few days already on it. This is, I think, the third day we're doing factoring. So there has to be a good reason for learning how to factor. And there are a number of good reasons. One of the major good reasons is to be able to solve a type of equation that is called a quadratic equation. We started out the term solving equations. The type of equations that we were solving were called linear equations. They were equations that had just plain x's, no x squared, no square root of x, nothing. The highest exponent you could have on a linear equation is 1. In other words, you'll never see an exponent, because when you have an exponent of 1, you don't have to put in that exponent. And those are the ones that we learned how to solve. And we reviewed how to solve, because I really expected you to know how to do that. And we also talked about graphing of linear equations. They also didn't have any squares or cubes or any exponents, and we knew they gave us, when we graphed them, straight lines. And that's why we called them linear equations. But another way of calling them is first degree equations. What the degree being the highest exponent, a first degree equation only has an exponent of 1. Now we're up to the next step. Quadratic equations are also called second degree equations. In other words, we're now up to solving equations that have an x squared in them, that have an exponent in them. And actually, some of the methods that we're going to use will help us not only do second degree, but let's say third degree or fourth degree equations. We will concentrate on how to solve what we call quadratic equations. We will always recognize that the type of equation we have is a quadratic equation because you're going to see an exponent in it. And the simplest method of solving quadratic equations involves using factoring. So that's why it's so important to be able to factor. Now, what is the whole concept of solving a quadratic equation based on? It's based on what's called the property of zero. Let's say I have two numbers. I'm going to call one number A and one number B. I don't know what they are. They're variables. They don't necessarily have to be. They might be the same number, but they could be different numbers. The only thing I know about it is that when I multiply the A times the B, my answer turns out to be 0. Now, there's something very special about it. What do we know happens when your answer when you multiply is 0? What do you know about your original numbers? Does anybody have any idea?
That one of them is a 0.
Right, perfect. That's what's called the property of 0. It means that either the first number, the A, has to be equal to 0, or the second number has to be the 0. Or they both could be 0, because 0 times 0 is also 0. But it's not possible for A and B to be different numbers other than 0, like one being a half and one being a third. Then when you multiply them, you're not going to get 0 as your answer. As soon as you know that your answer is going to be 0, it means that one of your numbers must have been 0 to start out with. So how does this work with solving a quadratic equation? So let's take a simple quadratic equation. Let's say I gave you x squared minus 5x minus 6 equals 0. I will recognize this as a quadratic equation because I see an x squared in it. It's not a regular linear equation. We have a different method of solving it. When I see that I have a quadratic equation, and a lot of people say, oh, because it equals 0. That's not what makes it a quadratic equation. What makes it equal to a quadratic equation is an exponent. In that case, make sure that your equation is in what we call descending order, x squared, x number, whatever, but always starting with the x squared, and it has to equal 0. If it's not in that format, you've got to push it into that format. So this is in the proper format. Now, if you notice, the x squared minus 5x minus 6 happens to be a trinomial that we just learned how to factor. Let's factor x squared minus 5x minus 6. Okay, remember for trinomials, we use our AC method. What is our AC in this case?
-6.
-6, because this is a y.
-6.
Okay, negative means that one number is going to be positive, one's going to be negative, and they have to multiply to 6. And when I subtract it, because this is a minus, my answer is going to be 5. What do I get? What number multiply to 6, but when I subtract them, give me 5? Anybody?
It'll be
Negative
-6 and 1.
for +1. No,
It'll be 6 and 1. Be careful, don't do, say it's 3 and 2, even though 3 and 2 multiply to 6. They don't subtract to 5, they add to 5. So we have to be careful. When this sign is minus, they have to subtract to 5, and yes, it's 6 and 1. And since that middle term is negative, it's the 6 that's going to be negative, and the 5, the 1, or the plain x is going to be the positive. I should put a 1 here. 6 is here. And then I just bring down my x squared and my negative 6. And I finish factoring. X squared plus 1x has a common factor of x. So this becomes x plus 1. And negative 6x minus 6 has a common factor, well, 6, but it has to start with a negative, so it's negative 6. And negative 6 into negative 6x is x. Negative 6 into negative 6 is plus 1. And if I, okay. So therefore, I now have to put the x plus 1 in the front. And in the second parentheses, we get x minus 6. And of course, this was equal to 0. In other words, I took this trinomial and factored it into my two binomials. Now, the two binomials, this x plus 1 is one number. This x minus 6 is some other number. In other words, if x is 20, x plus 1 would be 20 plus 1 would be 21. And x minus 6 would be 20 minus 6, which would be 14. In other words, I don't know what x is equal to, but certainly x plus 1 is one number. It's like my A. And x minus 6 is some different number. It's my B. But what do we see? We see that when we're multiplying these two numbers together, the answer is giving me 0. And what I said before, from the property of 0, it must mean that either the first number, the x plus 1, equals 0, or the second number, which is the x minus 6, has to equal to 0. And it turns out that from the one complicated equation, I end up with two much simpler equations. I know how to solve x plus 1 equal to 0. I just bring the 1 to the other side, and that gives me x equals negative 1. And on the x minus 6 equals 0, I add 6 to both sides, and I get x equal to 6. So that my final answer to this particular example is x equals negative 1 and x equals 6. In other words, and this is something that's going to happen a lot, with a quadratic equation, when you have a degree 2, when your exponent is 2, the number of answers you get is 2. It goes even further. If your degree would be 3, if you had an x to the third, you'd end up with 3 answers. We're not going to do too much with
Professor, your thing is breaking up
what we
again.
call cubic equations or exponents with, and that's why you start out with your example equaling to 0, so that you can use this property of 0. And now this is one of the major sorry. I don't know why it cut out, it keeps cutting out like that on me. I'm sorry. So that we end up with when we start with a quadratic equation, we end up with two solutions. Okay, I think I went back to where you were when you cut out. Are we okay, Cheryl? You followed that? Okay,
Miss
great.
Pearl, did you do attendance? I'm sorry, it's
Not yet.
Messiah.
Not yet.
Okay.
But I'm gonna do it as soon as I'm gonna have to see what I can do with my modem over the weekend and see if maybe I may need to buy a new modem. I'm really sorry about that.
Okay.
In the meantime, hopefully the rest of the class will work out. Okay, so I want to do one more example with you together. And then I'm going to give you an example to try and see if you can, while you're trying the example, I will take attendance. So let's take an example like this. Suppose I gave you this example. I'm going to do this one, then you get to do the next one. I have 3y squared minus y equals 4. And I want to solve 3y squared, I'm sorry. And I want to solve this equation. And it's obvious to me that it's a quadratic equation because I see a y to the second. I see an exponent of 2. So according to my rule, what I first have to do is get it equal to 0. When I want to solve a quadratic equation, I want to get it equal to 0. And in order to get it equal to 0, this 4 is giving me a problem. I want to get the 4 away from here, so I'm going to subtract 4 from both sides. In other words, contrary to the way we've already done linear equations where we got all the x's on one side and all the numbers on the other side, when it's a quadratic equation, when we have an exponent, we need everything on one side and only 0 on the other side. So this gives me 3y squared minus y minus 4 equals 0. And the next thing I want to do is factor. Now, notice this whole method depends on being able to factor. This is for you, trying to think who was that asked, Erica. We're going to talk about what happens when you can't factor it, but it's not today. That's the kind of questions that you were asking about. Okay, we're going to try and factor this, break it up into 2 parentheses. So the first thing I do, I have to use I look if there's a common factor, and there isn't because 3 doesn't go into everything. So I multiply the a times the c. My AC comes out to be 3 times -4, which is -12. Somehow, all the examples that we've done so far have the AC being negative. I probably is more common that the AC comes out to be negative than it comes out to be positive. But that's 6 of one and half a dozen of the other. It's negative, so we know that, and I'm going to put the negative first. I usually put the plus first and negative, but let's do it the opposite way. I know that I have to break this up into two numbers, that one will be positive and one will be negative. Now, if you notice, this says negative y. That really, of course, means it's a negative 1y. So what I'm looking for are two numbers that when I multiply them will give me 12. But when I subtract them, because this is negative, it's going to give me 1. And those numbers are obviously 4 times 3, because 4 times 3 give you 12, and 4 minus 3 give you 1. But since this is a negative, the 4 is going to have to be the negative, and the 3 is going to be the positive. So here are my two, don't forget to put those letters. In this case, I'm not putting X, I'm putting Y, because the example is Y. So I get 3y squared. I bring that down, and I bring down the negative 4, and I'm ready to factor it. So I look at the 3y squared minus 4y, that group. The only thing they have in common is a y. This has a y squared, this has a y. So therefore, my common factor is just plain y. I put the y on the outside. Y into 3y squared is 3y. And y into negative 4y, the y's cancels out, and it just leaves me negative 4. In my second group, which is 3y minus 4, there's no common factor. But remember, I can't just leave it blank. I have to have something in front of the next parentheses. So when there's no common factor, I just put a plus 1. Sometimes the common factor is negative 1, but in this case, it's plus 1. You put a plus 1 on the outside. And of course, 1 into 3y gives you 3y. And 1 into negative 4 gives you negative 4. So that my common binomial factor ends up being the 3y minus 4. And the other factor, the numbers that are on the outside are the y plus 1. Now I'm going back and I'm putting this equal to 0 because this whole thing was equal to 0. I know I don't stop here. This is not a factoring question. This is a quadratic equation. We have to get a final answer from our variable. So what I do now is I separate it. I take the 3y minus 4 and set it equal to 0. And I take the y plus 1 and set that equal to 0. And I solve each of these what I call secondary equations. 3y minus 4, the first thing I have to do is add 4 to both sides. So I get 3y equals 4, and I divide by 3. So I get 4 over 3 as one answer. And here I subtract 1 from both sides, and I get y equals negative 1. In other words, my answers are 2, 4/3 and negative 1. I get 2 separate answers. That is how we solve a quadratic equation as long as we can factor it. We're going to talk about next time what happens if we can't factor it. What should we do in that case? There are other methods, but this is the standard method. You'll see it's a quadratic equation because you have a square. You're going to make sure it's equal to 0. You're going to factor it, and you're going to set each factor equal to 0 and solve those two secondary equations. It all boils down to getting it into two simpler equations. Are you ready to try one on your own? Are we okay? So let me give you, I'll start with an easier one and then I'll give you a harder one. Okay. Okay, yeah, it's a lot of steps. Notice this is where you would have stopped if all you had to do was factoring. You have to go this much further when it says, and be very careful, read the instructions. Because if it says factor, there should be no equal sign in the whole example, and you should just break it up. But if it says solve for whatever, in this case, it would be y, and you see it's an equation because it has an equal sign, you have to go all the way to the end. Okay, can I erase this?
Professor,
Yes.
how did you get the 4/3?
Okay, one of the factors was 3y minus 4, right?
Yeah.
So I set that equal to 0. So I got 3y minus 4 equals 0.
Mhm.
Now, that's a regular equation. It doesn't have any squares. So I know I have to get the variable on one side and the number on the other side. So I add 4 to both sides to get the 4 to the other side.
Mhm.
That gives me 3y equals 4.
Yeah.
And then to get the y alone, I have to divide by 3. So that gives me 4/3.
Okay.
So when after you've factored it, you separate it and do 2 separate equations that are easy equations. They're not hard equations because they don't have any squares anymore. Okay, here's an example for you to try while I take attendance. X squared plus x minus 20 equals 2x. I would like you to solve, it has an equal sign and it's a quadratic equation. I want you to solve this quadratic equation. I'm going to give you time to solve it while I take attendance. Put the recording back up. Okay. What did you do first, Stacia?
Okay, so at first I grouped all my terms to one side, which will be equal to 0. So I
Okay.
had 2x.
So you had to bring this 2x to the other side, right?
Yeah.
So it became minus 2x, okay. Notice she saw it was, let me just do a little preliminary work. Once you see this x squared or any exponent on your variable in your equation, you don't have to be told it's a quadratic equation. You know it's a quadratic equation. And that means you have to get it equal to 0, which means you look on the other side and there's a 2x there. You want to get rid of that 2x, so she's subtracting 2x. What did that give you?
X to the second power plus x.
Is it plus x?
Yes, that's a plus, right?
This is a plus, but we're subtracting 2x from it, right?
Oh, I did it. I brought over everything and then I equaled it to 0. I didn't subtract anything there.
Oh, all right. Okay, so let me hear what you did. Okay, you have x squared
Yeah.
plus
Plus x minus 20
I'm following you, minus 20.
minus 2x
Okay,
equals 0.
okay. So she used what we call the transposition method, where she wanted to bring, this is a positive 2x, so she brought it to the other side, made a negative 2x. Okay, and then what did you do?
I used the AC method. The AC
Wait
method,
a
which would
second, it's
be,
not a I can't do a C method until I have everything combined. What about this one? This is a 1x. and this is a negative 2x. Don't we have to get those together first?
Oh, yes, I didn't do that part.
Okay, so let's do that. That's why I was putting it under the x. But we really want to combine the like terms. Before we try to do any, I want to make sure that it's in the format. So how much does that, what does that give you? How much is 1x and minus 2x together give you? Am I coming, are you losing me again?
That would be give me 2x. Sorry,
Well,
1x.
a plus 1x minus 2x.
3x.
A plus 1 and a minus 2? You could do it
No,
on your
1.
computer. Right, and is it a plus 1 or a minus 1?
That would be a -1.
Right, because the larger number is negative. So this is a negative 1x. That's just combining this term with this term. And then now you have your negative 20. Now you can use your AC method. Okay, if we want to use our AC method, what is my A and what is my C? What will I get when I do AC? Okay, you know what? I see I'm getting too many. I'm going to take it over from and go back because I see a couple people are saying they're confused. So let's go back to the beginning. Thank you, Stacy. I appreciate it. It's just that I need to do this. I guess
Sure.
more for those people who are having a little bit of a hard time. Okay, Cheryl, this is for you. I see I have an x squared. Once I have an x squared in my equation, I know I have what's called a quadratic equation. And a quadratic equation is solved by bringing everything from one side of the equation and setting it equal to 0. So I have this 2x. I don't want the 2x. I want it to be equal to 0. So I want to get rid of this 2x. Now this is a positive 2x, so I'm going to subtract 2x. Now I could put the negative 2x at the end, but I'd like to put it under its like term, so I'm putting it over here. Because I'm trying to combine as I do the problem. So I bring down the x squared. This is a plus x, which really means a plus 1x. So I have a plus 1x together with a negative 2x, which is a negative 1x. And a negative 20, there's nothing to combine with that. And here, the 2x minus the 2x equals 0. So now I have it set up in the proper format for solving a quadratic equation. So the first thing is I have to decide it's a quadratic equation. The second thing is to make sure it's set up properly. Everything on one side in what we call descending order, the x squared, the x, and the number equaling to 0. Then we can do the factoring. Now the factoring, in this case, since it's a trinomial, we're going to figure out what our AC is. The A here is 1. The C is negative 20. So AC is 1 times negative 20, which is negative 20. And that means I'm looking, since it's negative, for one number that's positive and the other number being negative, so that when I multiply them, I'll get a negative. That when I subtract them, because this says minus 20, so I have to subtract them, will give me 1. Now, what number gives me 1 when I subtract them, but when I multiply them, give me 20. And I see Stacia said they have to be 5 and 4, because 5 times 4 is 20, but 5 minus 4 is 1. And the 5 is the one that's going to be the negative, because the middle term being negative means my bigger number is going to be the negative number. So this is going to be an x, and this is going to be an x, and I'm going to bring down my x squared here and my 20 over here, my negative 20. I really should write equal to 0, but we know in the end I'll put equal to 0. The first thing I want to do is factor. So in my first group of 2, I have an x squared and a 4x, which has a common factor of x. So this becomes x times x plus 4. In my second group, I have a negative 5 and a negative 20. I have a common factor of negative 5. So negative 5 into negative 5x gives me x, and negative 5 into negative 20 gives me plus 4. So that in the end, my factoring is the x plus 4 in one parenthesis, and then the other parentheses
Professor?
I think she gone this time.
All right, her internet is acting up. Just give her like a minute.
I'm back. I'm sorry. I don't know what I'm gonna have to. Everybody in my house is being thrown off the internet. We don't know why. Okay.
Professor, you're muted. You're muted. We can't hear you because you're muted. Your mic is mute.
Sorry. Thank you for telling me. I don't know why I keep going and we're having such a problem. I am so sorry about this. I hope that this doesn't happen again. Okay, so that, I'll repeat what I said before. The answers are -4 and +5. And I'm guaranteeing you, if they gave a question like this on the midterm, and there will be a question similar to this on the midterm, one of the answers they're going to give you is +4 and -5. They know you probably know what to do, but you might make a mistake with the signs. So it's really possible to get through the whole thing and make a stupid mistake and pick the wrong answer. Be very careful with your signs. Okay, now I'm going to leave this topic here now because I really want to do some review for the Blackboard test. I'm going to do some today and some Tuesday. So if you really feel you want the review, don't sit down and try to do that test until after Tuesday. I'm going to give you at least till the end of the week, until Friday, to do that Blackboard test. So if you, I'm going to do some review today. Whatever we don't finish today, we'll do some on Tuesday. We have basically finished the topics for the midterm. The Blackboard test that I gave you does not include this. It doesn't include the factoring. It doesn't include the quadratic equation. But that will certainly be included in the midterm. So we're really pretty much finished with the material for the midterm. So so the review that I'm doing today will also help you to prepare for the midterm as well. So the first thing I want to do is remind you, I'm not going to do a regular equation. I think we've done enough of the regular equations, but let's say gave you an equation like this to solve. -3.8x plus 1.2 equals -25.8 minus 1.1x. Let's just review how to solve an equation that has decimals in it. Next week, I'm going to start talking about chapter 5, and chapter 5 is going to be on fractions. And the first thing I'm going to show you is how to solve equations that have fractions in them. So now let's just concentrate on the decimals. And I'm going to give you a couple of minutes to try this example. remembering that you're allowed to use a calculator. You don't want to be using one of these calculators, graphing calculators. You're really only supposed to be using a regular scientific calculators. But certainly when you have more difficult numbers, and decimals are a bit more difficult, try and use your calculator. Let's remember that when we have an equation, it's not a quadratic equation because there are no x squares. It's a regular linear or first degree equation. We want to bring the x's to one side and the numbers to the other side. And I usually like to have the x's on the left side and the numbers on the right side. So the first thing I see is I'm going to leave this negative 3.8x here, but this 1.2 I'm going to subtract because I don't want the plain numbers in the equation. On the left side of the equation. So that'll leave me negative 3.8x. This we've I'm going to do negative 25.8 minus 1.2, and that gives me Am I still frozen?
No.
Okay, good. Okay, let me see if I can. Okay. All right, so we got that the negative 25.8 together with a negative 1.2 combined gave me negative 27. And I still have this negative 1.1x. Well, now I want to get this term to the other side because I want all the x's on the left. So I'm going to add 1.1x to both sides. Again, I don't like doing this without a calculator. So in my calculator, I'm going to put in negative 3.8 plus 1.1. I'm not putting in the x's, but I'm putting in the coefficients, which gives me negative 2.7. So this gives me negative 2.7x equals negative 27. And just like we have in any regular equation, we divide by the coefficient of the x, negative 2.7. And again, I can do this on my calculator. And when I do negative 27, remember you put that in first and then push your divide button and do negative 2.7, it gives you 10 as your answer. And the correct answer to this question, you were right, Zia, was 10. What makes this hard is not somehow people get a little bit edgy. To put another question on the board. Can I erase it? Oh, I'm sorry, I keep getting this internet is unstable. Okay, I'm gonna erase it now. And put on another problem on the board. This is, just to remind you, how to solve an inequality. I want you to solve this inequality, and I want you to put it in interval notation. So it's -4 times 2x minus 4 is less than -12x plus 28. Okay, let's see if you can solve this inequality and put your answer in interval notation. Didn't ask you to graph it. It just said put it in interval notation. But if you want, you could graph it as well, but we're going to put it in interval notation. Okay, I see. Cheryl, you got an answer, but isn't, remember, it's an inequality, so you have to write your answer in interval notation. You can't just write a number. Okay, I see a few people have gotten their answers, so let's work on it together. As a reminder to how to do, this is what we call a linear inequality because we have a less than sign. Just like in any regular equation, we're going to remove the parentheses by multiplying by -4, so they'll give me -8x. -4 times -4 is +16, is less than, remember, we keep the direction of the inequality the same, -12x plus 28. And when we're solving an inequality, we absolutely want to make sure the x's end up on the left and the numbers on the right. So the first thing I'm going to do is I'm going to minus the 16 from both sides so that I won't have any regular numbers here, just x's. So this will give me -x This cancels out, is less than negative 12x, and 28 and negative 16 gives me plus 12. Then I want to bring this negative 12x to the other side. So I'm going to do plus 12x because I want all the x's on the left. So this is exactly like you would do on like a regular equation. Negative 8x and 12x gives you 4x. This still stays a less than. This cancels out, and this gives you 12. And the last step is, of course, to divide by the coefficient of the x. In this case, the number in front of the x is a 4, so I'm going to divide both sides by 4. Here's where I have to be careful. If this number would have been a negative number, I would have had to switch the direction of the inequality. But I'm not. I'm dividing by a positive number, so I leave it the same so that my final answer comes out to be x less than 3. This is not interval notation. This is as an inequality. X less than 3. And you can't just say 3. You have to say x less than 3. In terms of if they would ask you for the graph of this, which they didn't, but if they had asked you, on the number line, you would have gone to the number 3. Since it says just less than, and it doesn't have an equal sign, you make it an open circle. And notice this looks an arrow pointing to the left, so therefore this is going to the left. But they didn't ask for this, but they asked for interval notation. In interval notation, you're going to have the starting number, a comma, the ending number, and then you're going to either have parentheses or brackets. Now, since this is, and you're always starting on the left, all the way, since it's pointing all the way to the left, that means it's coming from negative infinity. And it's stopping at 3, so it's comma 3. Wherever you have an infinity sign, you always put a parentheses. By the number itself, if it's an open circle, it's a parentheses. If it's a filled in circle, which it would be if we had a less than or equal sign, then we would have made this into a square bracket. But this is not, so it's parentheses, negative infinity, comma 3. This is how your answer would look in interval notation. Okay. Any question about that? Okay, so let's try another example. What if I gave you something like this? Here's my next example. It says solve the absolute value equation. So what if I gave you something like this? The absolute value of 2x plus 5 minus 4 equals 13. Okay, let's try doing this. I know that you might not be finished, but I just want to do this and basically two other type of problems. When you have an absolute value equation, the first thing you want to do is to make sure that you have your absolute value all by itself. If there's anything outside the absolute value, you have to bring it to the other side. So this -4, I'm going to add 4 to both sides to isolate the absolute value. So I'll get 2x plus 5 in the absolute value side equals 17. And I pause. I stop and look at this number because this number has to be a positive number. If it's a negative number, you stop right there because it's impossible for an absolute value to be equal to a negative number. So there can't be any solution. But this is a positive number, so we can go further. We go further by breaking this up into two equations. The first equation becomes 2x plus 5 equals 17. And the second equation comes out to be 2x plus 5 equals -17. Don't forget that you're going to be getting two equations, one with a positive number and one with a negative. And you solve both of these equations. In this one, you subtract 5 from both sides, which will give you 2x equals 17 minus 5, which is 12, and divide by 2. So that gives you x equals 6. So one answer is x equals 6. Don't stop there. This one, you subtract 5 from both sides, and it gives you 2x equals, well, -17 and -5 is -22. And divide by 2, and you get x equals -11. So you get two answers, which I saw a few people did put in both answers. Don't forget, you must give both answers. If this is on a test, probably one question, it'll just give you one answer and not give you the other, because they know that's a common thing that you could do. Okay, so that was this. Let's talk about, that really takes care of chapter 1, the type of questions, regular linear equations, and then inequalities and absolute value equations. And then we'll continue with the review on Tuesday. Sorry. Okay. So let's remember what it means for a line to have a slope of 0. What kind of lines have slopes of 0? And if you remember, a line that is a horizontal line, a one that goes straight across, its slope is 0. So if it says it's going through the point 5, -3, here's the point 5, 1, 2, -3. What we're asking for is the equation of this line. Now, if you remember what we said, horizontal lines always have equations y equal a number. A horizontal line will not have an x in its equation. And if it tells you the slope of the line is 0, you know you're dealing with a horizontal line. It means you're dealing with this line, the line y equals. So all you have to do is look at the y value and you do y equals -3. This is the equation of that line. Horizontal lines always go y equals a number. You'll always be able to tell what the number is by looking at the y value. Equally, they could talk about, what about a line that is vertical? What if they told me I have a vertical line through the point 1, -2? Well, let's see what that would look like. A vertical line is a line that goes straight up and down. So here's the point 1, -2. Here's that vertical line. Goes straight up and down. By the way, if it's vertical, it has, the slope is undefined. So they could have also said, what if we have a line whose slope is undefined? That means that you're dealing with a vertical line. Now, a horizontal line, we said, only has a y in its equation. A vertical line only has an x in its equation. Since the x here is 1, the equation of this line is x equals 1. So these are our two special lines. The horizontal line that always says y equals a number and has no x in the equation at all. And the vertical line, which has x equals a number and has no y in it. They're just the special two types of lines. We'll go on to the, what we call the slant lines on Tuesday. We'll review slant lines on Tuesday and systems of equations. Any question before we leave? Melissa?
Ms. Pearl,
Yes.
I have a question. It's Messiah. I was wondering, can I still turn in my late homework? I wasn't able to do it. I was having family issues.
No problem. You can always do the homework. First of all the homework assignments have a late date of in May. In other words,
Okay.
okay. Did you do the quizzes?
I didn't do the first quiz. I don't think so.
Okay, so then I will open up that first quiz as well.
All right. I don't know about the second quiz, but I know I didn't do the first quiz because I saw that it was late.
Okay, so I will make sure that it's opened up. Again, if anybody is entitled to double time from you have to send me an email so I know to set it up for you.
Okay.
Okay, I don't know if it's you, Messiah, but there might be somebody in the class that is entitled to double time.
Professor,
Yes.
the one that we had on it for the extra credit, could you reopen that one for me, please? Reset it?
It should be still open.
No, could you like reset it?
Oh, sure.
All right,
I
thank you.
certainly will.
All right.